Hello and welcome to The Explainer. I am absolutely thrilled you're here because today we are unpacking something truly fascinating. We're impartially exploring a radical, highly debated alternative text that proposes not just a wildly different geological history of Earth, but a complete ground-up overhaul of how science is taught in our schools. Whether you find the claims we're about to look at brilliant, totally provocative, or somewhere in between, there is no denying that the educational philosophy behind them is incredibly thought-provoking. So we're going to examine this theory exactly as the author laid it out and see how it aims to literally change the way students learn about the world right beneath their feet. Okay, let's dive into this. Here is our roadmap for today. First, the scientific patchwork. Second, the small bang theory. Then, a unified roadmap, followed by the new textbooks, and finally, we'll wrap it all up with raising true knowledge creators. Section 1. The scientific patchwork. The problem with current science education. So, before proposing any kind of new geological timeline, the source takes a really hard look at our current school system. And to frame this critique, the author actually points to a famous quote by the physicist Max Planck. He said, "A new theory never triumphs. Only the followers of the old theory eventually die out." Basically, the text is arguing that the academic establishment clings to these fragmented, outdated models, and the ultimate victims of that stubbornness are the students. Now, what's really interesting here is that the author identifies several massive geological events as unexplained anomalies in current textbooks. Right now, established science treats things like the exact origin of the moon, the source of our massive oceans, the sudden extinction of the dinosaurs, and even the mechanics of tectonic plates as this giant patchwork of isolated mysteries, meaning you need a multitude of completely different, sometimes conflicting theories to explain them all. And this brings us right to the author's core critique of the classroom experience. Because established science constantly has to just say, well, we don't know, when it comes to a single unified cause, students are pushed into a really frustrating corner. They're forced into this tedious process of rote memorization, what the text calls auswendig lernen. They literally have to memorize a disconnected patchwork rug, a flicking teppich, of random facts, dates, and separate theories. The author argues this absolutely crushes a student's natural curiosity and stops them from ever seeing the real cause and effect relationships in nature. Moving on to Section 2, the small bang theory, a proposed singular cause. So to fix this fragmented curriculum, the source asks us to entertain a pretty wild question. What if one single geological event caused all of those anomalies at the exact same time? Enter the small bang theory. It's framed as this massive, all-encompassing alternative designed to completely simplify how science is taught. I mean, think about it. If one event could explain the moon, the oceans, the dinosaurs, and the continents, teaching science would suddenly become incredibly simple and logically streamlined, right? So what actually is this event? Let's take a look at the author's radical geological timeline. And just a quick note, Ga stands for gigaannum, or billion years ago, and Ma is megaannum, million years ago. Okay, according to the text, 4.6 billion years ago, a liquid Earth formed. Fast forward to 541 million years ago, a thick, solid granite crust completely seals the planet, kind of like a giant pressure cooker. And then, exactly 66 million years ago, the pressure just becomes way too intense, triggering the titular small bang event. Let's break down the mechanics of this proposed 66 million-year-old event. First up, immense pressure builds under a 20 to 60 kilometer thick granite crust. Eventually, it cracks right down the equator. This causes the entire Earth to violently rupture and actually expand, shedding mass out into space. Now, the text states this shrank the Earth's radius from 6,410 kilometers down to the 6,371 kilometers we have today. Finally, all that ejected material clumps together to form our moon, while the sudden pressure release allows internal water to essentially sweat out, rapidly filling up our modern oceans. Which leads us to Section 3. A unified roadmap, replacing the patchwork. Now, the author's ultimate goal here is to transform the curriculum into an einheitliches Fahrplangerüst, a totally unified roadmap. And this beautifully illustrates the point. Instead of teaching three separate massive cosmic events like asteroid impacts or icy comets crashing into us, the small bang model unifies the whole thing. The Earth's rupture shifts the habitats, killing the dinosaurs, the internal sweating creates the oceans, and the ejected crust forms the moon. Boom, one single event. To make this super easy for students to digest, the author uses this really catchy slogan, "What the Big Bang was for the universe, the small bang was for Earth."
The text argues that, just as the Big Bang gives us a singular starting point for understanding cosmic expansion, the small bang gives us one causal starting point for understanding all modern geology and geography. It's basically an attempt to simplify billions of years of incredibly complex science into one universally applicable concept that any student can grasp right away. Section 4. The New Textbooks. Rewriting the Curriculum. The source material makes it crystal clear. This theory isn't just a thought experiment. It's meant to be pushed directly into physical classrooms. The author is arguing for a total paradigm shift. You can't just slap the small bang theory into a sidebar as a fun alternate hypothesis. No, because it fundamentally alters the timeline. Literally every textbook would have to be completely rewritten around this single causal event. The whole curriculum has to shift away from isolated theories to one continuous story of planetary maturation. And the author is incredibly confident this shift needs to happen, actually issuing a pretty direct challenge to the current scientific establishment. The text warns scientists to imagine a future where their own grandchildren look at them and ask, Grandpa, how could you actually overlook the small bang theory for so long? The argument is that future generations are going to look back at today's patchwork science in total disbelief, judging modern academics for missing what the author sees as an incredibly obvious, unified solution.
So, practically speaking, how long does the author think this entire revolution is going to take? 10 years. 10 years is the estimated minimum time needed to overcome academic resistance, force the establishment to accept this brand new paradigm, and then physically rewrite, print, and distribute the countless school textbooks required to teach the small bang theory to the next generation. Section 5. Raising True Knowledge Creators. The ultimate educational goal. This brings us to the absolute climax of the author's vision, which is the psychological and intellectual transformation of the student. The text draws this incredibly stark contrast between two types of learners. On one hand, you have the narrative bavara, the narrative preservers. These are the students produced by the current system who just passively memorize unquestioned, disconnected facts. But on the other side, you have the Wissenschaftende, the true knowledge creators. Because the small bang theory relies on observable physical mechanics, the author argues it actively trains students to become logical, causal thinkers. So the crucial takeaway here is this bold vision for the classroom of the future. If the SBT actually integrates into our schools, the author believes science education will be completely revitalized. That frustrating "we don't know" is totally eliminated. Geography and biology, no longer separate silos, but logically linked by one massive planetary event. The whole focus of learning shifts to cause and effect. Students could actually sit down and calculate real physical mechanics, like the escape velocity of the moon's material, making science feel like an exciting, unified story rather than just a dry list of facts to memorize for a test. And that brings us to the end of our explainer. Regardless of whether you buy into this highly radical geological theory or if you stand firmly with established science, the text leaves us with a seriously provocative question about the very philosophy of education. Are we currently building a system that forces the next generation to just passively memorize the past, or are we striving for a unified curriculum that actually gives them the tools to logically deduce and create the future? It is a fascinating lens through which to look at how we teach the next generation. Thank you so much for exploring this with me today, and hey, keep questioning the world around you.